Hey guys, this is the video tutorial series of modern electronic fuel injection, which is actually the engine management systems, how they work, and how a computer basically runs an engine and how it handles different jobs, and ultimately it's also going to show you how uh, to make this thing happen, how to tune, how to be able to order certain components to perform certain tasks, right? But so sorry that we can't just jump straight into that subject, because to be able to control something, you actually need to know what that thing is, leave alone, what its functionalities are in depth, So first we have to know what that thing is, and then we also have to kind of dwell into a sufficient amount of depth, so that we are acquainted with all its features and how it functions, and what are the safe limits to it, and what are all the different criteria that we need to know. So let's get started. Like I said, we have to start right from the basics, from the building blocks. So we will start with the chapter 1, which is engine composition. Engine composition is going to cover what components make up an engine, right? And then we are also going to discuss their functionalities and their limitations, or whatever information is necessary to get you guys kick-started. We will get into it. So to start off, we will first start off with four-stroke cycle. Four-stroke cycle is essentially the core of any engine, right? 90% of the engines that we have, I suppose, are four-stroke cycle engines. They have two-stroke cycle, they have rotor engines, they have, but let's just not worry about that for now, because we will only be dealing with this, because this is what applies to 90% of the cars out there. So I'm assuming that everybody should be knowing at least what a piston, connecting rod, let me turn on this, yeah, okay, a piston, a connecting rod, a crankshaft, valves, what they are. And if you don't know it, just be patient, we'll be discussing that in a while. So let's start with the first thing. Four-stroke cycle, the name says it all, is actually four strokes make up one cycle, or you can call it four strokes, meaning four movements of the piston, right, make one cycle, right? So let's start with the cycle. I just don't want to confuse you with the revolution. Let's start with the cycle. Okay, so this is what happens, right? Your piston in your first stroke, right? Your piston is all the way on the top, which is called the top dead center, right? It can't go any further than that, right? Because this is like in a revolving, it's connected to the connecting rod, and connecting rod is connected to the crankshaft. And as you can see, the crankshaft, when it turns in a circular direction, this on the other hand goes in a reciprocating manner, in a perpendicular fashion, right? Up and down it goes. So when the crankshaft is gonna revolve and reach almost here, that's the max it can go up to, is here. That's how they've designed it, for it to reach its top. So when it's at its peak, it's called top dead center, right? Try to remember this name, TDC, top dead center. Is a very important thing in the engine. You're gonna deal with this a lot later on, because everything is measured based on that. So just don't worry about it now so much, but get yourself acquainted with this terminology, TDC, top dead center. So okay, so your piston, the first stroke begins with the piston being at its top dead center, and it starts to move down, right? Let's say you are cranking up the engine, and the starter motor is actually trying to turn it, and it is moving down. While it is doing that, the intake valve opens, right? How does it open? It has a camshaft revolving on top of it, which pushes it down and it opens. All that we're going to be dealing with in detail after some time, so just bear with me. So yeah, so intake valve allows the intake, which is your air fuel mixture, which is your fresh air that is being sucked in by the engine, because this piston is like a big huge syringe. When it's moving down, obviously when you pull down the syringe, is going to suck in the air, and when you push it, it's gonna send it out. So that's exactly what happens, right? This is a pump, so it's gonna come down, suck in the air from the atmosphere, and at the same time injectors are going to squirt some fuel inside, so a good mixture is gonna go in. How much does it squirt? Don't worry about it right now. We will deal with that, what is an ideal fuel mixture and what does what, and everything else we're gonna deal with later on. So as it goes down, the cylinder is now filled with air fuel mixture, right? Okay, now is this air fuel mixture any good? Not yet, because this air fuel mixture, if you ignite it now, it's not gonna make a big amount of power. It's just gonna burn and waste itself, right? It's not really I should not say this, but it's not really explosive right now, right? Then at the second stroke, so this is what you call as your intake stroke. Air fuel mixture is drawn in. How is it drawn in? Because this is like a syringe, it's a huge pump. When it comes down, it obviously has to suck in, right, the oxygen. Now what happens? Compression is your second stroke. Now you see it has completed the revolution all the way, and it would have been here somewhere, when it reached it was here when it reached the BDC, bottom dead center, which is not does not require any explanation. It's your opposite of your top dead center. So once it reaches here, now it starts revolving back again, because this is the momentum of the crankshaft, yeah, because crankshaft is going to turn like this, and it's going to now push it back up again. So as it's doing that mechanically, right, both of these valves have closed. So what's going to happen if you close both the valves and the piston is going up, the syringe is going up, and you have stuck your finger at the tip of the needle, it's like you're going to be compressing it. So that's exactly what's going to happen. It at this point of time, when the piston is forced up, the starter motor is forcing it up, let's say, and it gets compressed. When it starts compressing, what happens is that this thing almost like turns into gas. What do they call that thing? The atomization symbol. Yeah, so it's like almost like turning into a gas. That gas is ready to not explode, ready for combustion. Explosion is something that happens during knock, which is really an unwanted thing. So we see here they are calling it explosion, but explosion is not the correct thing, although you can say it that way, but this is slightly lesser than the explosion, because it burns in a in a pattern, in a manner which is suitable with the, let's not get into that, but we will deal with all this thing later on when we study about knock control and stuff like that, knock detection and control and all that. So when the piston is up, it has compressed now everything. Then we move on to the third stroke, which you call as the power stroke, right? What happens is when it's on top, TDC again, top dead center, both valves are still closed, right? Notice this, right? Then the spark plug is commanded by the ECU, in most, we are dealing with modern, fuel injection system. So it is the ECU. Don't worry about the other stuff, right? So the spark happens and boom, bang, or whatever you want to call it. This is like pushed down rapidly, boom, it goes down. Because, obviously, this, okay, maybe you can use it this time only. It explodes and boom, it goes down, right? So when it goes down, obviously, like the momentum again wants to push it up. So then we, transfer to the exhaust stroke, which is the exhaust valve has opened now, right? And your piston is going up and all the exhaust gas has been thrown out of the cylinder, right? Making room for some clean, fresh air here. Then the piston goes down and fresh air comes in, then it compresses, then there's a spark, and then, exhaust throws it again, then it comes, like it happens till, it's a never-ending story. It keeps happening. That's, but once these 4 strokes complete, you call it a 4-stroke cycle. It's one cycle, right? Okay. So a couple of things that we want to know. Many smart guys already know this, right? But they must have, I can bet you my life, they have never paid attention that this is how it looks like, right? In 4-stroke, only 2 times you have valves opening. In 2 strokes, your valves are closed. So the first stroke and your last stroke has open valves, and the 2 in the center, right? I know you know it, but this is a pattern. Try to feel it. That's how it goes. Because if you felt it, then you're gonna know what's an overlap, how a cam can disturb you, and how you have to know it right. On your, just like rule of your thumb. That which stroke happens after what and stuff like that. So always remember that intake is always happening after exhaust. Intake is always happening after exhaust. Intake is always happening after exhaust. Intake, study it. So, that's what's going to happen, right? First stroke, intake is open. Last stroke, exhaust is open, right? So how many times did intake valve open in your 4-stroke? Only once. How many times did your exhaust valve open in this? Only 1 time. Did any of the 2 valves open simultaneously during any stroke? No. Right? How many times were your valve closed? 2 times. So these are the things, when you know it, when you keep looking at this picture time and time again, I can tell you, I can assure you that you will master some of the key stuff of the engine, right? Looks as basic as though it may appear, but this thing has a lot of information right there, in advanced stuff. So anyway, so we get it now. This is 4-stroke, right? And know that 1 stroke, okay, I'm gonna take this opportunity and explain this to you. 1 cycle does not complete 1 revolution. Okay, many people get it wrong, or they never, you know, took some time to actually think about it, you know. Uh, Two strokes make one revolution, right? Because one stroke is gonna push this crankshaft 180 degrees, right? 360 degrees makes one complete circle. So half a circle is 180 degrees. So, when this is on TDC, this thing is gonna go all the way till here. So when it comes down, it's gonna reach here, right? So that is your 180 degree. Then again, it's gonna go up, So one revolution, of the flywheel, of the crankshaft, because flywheel is connected on one end of the engine, and another end is your main pulley and your other pulleys and stuff like that. So flywheel is hooked right onto your transmission. So yeah, I think I will not be discussing transmission and other stuff in this. Maybe in this series, maybe we're gonna deal with that in some other mini tiny, stuff. So anyway, so remember that half a cycle is one revolution, right? Yeah, just remember that. Another revolution is the second half of one cycle, right? Okay. I'm emphasizing so much on this is because in the future lessons, when we discuss camshaft, we will, we'll be dealing with this subject. Camshaft actually completes one revolution in one cycle, right? So it rotates at half the speed of crankshaft to, to complete one cycle, just like so this is why I'm emphasizing on this, because camshaft, when we deal with it, you will know that it has to rotate at half the speed. So you heard it, you can forget about it, but when you come to camshaft, I'm gonna remind you back, so at least you can brush up your memory and get back on track. Yeah, so let's move on with this. I think we've spent enough time on this, but this is because this is quite significant in the whole stuff. So I think I'm kind of confident now that I think you have the grasp of how it works. Okay, so this is like a, what do you call that thing? Like a zoom in of the cylinder, where this is your combustion chamber. See here, it says the whole thing combustion chamber. I don't know if you want to call the whole thing your combustion chamber. I don't think that's right, but this is actually your cylinder. Combustion happens actually exactly this area, right? When the piston, this is your TDC, you see these two lines, this is your top dead center, right? This is your piston, this is your piston pin, this is your connecting rod, this is your cylinder, and if you have sleeves, they're gonna be here. The cylinder liner also they call it sleeve also. Yeah. So yeah, and this is your head. Above this, your top dead center is just kissing the head almost, so this is your head, and your head has two ports, the intake port and the exhaust port, and there are two gates on that, which you can call it a valve, right? So this is your exhaust valve and this is your intake valve, right? So let's say you have enormous pressure coming in, right? An injector is spraying all day. Can it pass through? No, it can't pass through because the valve is sitting. Soon as the camshaft pushes this valve down, this is gonna move front, and now you'll have some room in the side, right? So then the enormous pressure which was sitting right in the back, pressurizing it, trying to make itself make way in, as soon as it goes down, it's gonna push it and go. So that's why the valve spring is actually so hard that regardless of what pressure you're applying here, it will not be able to push this valve inwards, right? Only a camshaft with a mechanical force, a certain degree of force can push this down. So yeah, it also consumes a lot of energy because camshaft is driven with but yeah, let's not get into that. Yeah, so this is where your fresh stuff is gonna come in from, right? When this valve goes down, which means it opens, stuff is gonna come in and fill up this chamber, which is your combustion chamber, right? Actually, it's gonna fill up the whole cylinder, and when the piston goes up and compresses it, that's when it's stuck. The whole thing is stuck in your combustion chamber. So in this, I would like to take an opportunity and explain to you what a compression ratio is. A lot of people, they go like, oh man, what's your compression? Oh no, that's too high, and the turbo is gonna burn, and a lot of bull they say, but they don't know what actually a compression ratio is. A ratio means something is to something anyway. So it's a comparison or some conversion to certain thing, and so when you say 13 compression, obviously it means 13 is to 1, right? What does that mean? It means that your cylinder, let's say, had 13 liters of stuff, yeah, the mixture, air fuel mixture, and the piston compressed it 13 times, right? So the 13 became 1 now. You get it? So although it is in the size of 1, right, but it has power of 13, right? So I'm putting it in real ghetto terms, so yeah, so that's what happens. So compression 10 is to 1, 10.5 is to 1, meaning it's gonna push it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times and make it into a thick thing. Yeah, so that's how. And there's a thing about it's physics and stuff. When you compress something, it wants to expand, right? Any pressure wants to depressurize to become room ambient pressure. Any temperature wants to become room temperature. That's how God created us. Yeah, if you believe in God. Yeah, that everything wants to normalize. Nothing likes to be a weirdo kind of a thing. So anything that is over pressurized would want to go and just merge with the other thing and just become a regular thing. So that's why when you bring in a hot thing and you keep a hot cup of tea, it wants to become the room temperature, and you bring in a cold thing, it wants to become that. And when you bring too much pressure, so that's why when you have pressure here, it wants to depressurize or whatever you call it, and that's why when you spark it, it gets that energy to do it very fast. It gets certain energy, and that's all physics. Yep. Okay, now getting back to this, this is the exhaust port, right? The same thing. This exhaust valve is gonna go down when piston would be coming up, and all the gases will be pushed out. This goes completely in reverse order. Here in this in this intake, the flow was coming this way, and in the exhaust the flow is going that way, right? If you look at it, something I just noticed now, it doesn't look like an efficient design. Yeah, this one, when it's coming out, you see that this is like, the design is like kind of blocking it for it to come. And here, when it wants to go that way, that direction, you see this is trying to block it. So yeah, but yeah, it does not really block it though. Yeah, so yeah, and this is where your spark plug is sitting, right? And the spark, I don't want to, we have nothing to do with the spark thing, but that's where it sits. You see the tip right here, This is why you see this kind of combustion chamber, so strange. I remember on my 3S GTE engine, once upon a time, you have two sizes of spark plugs, right? You have for the Nissan engines, Nissan petrols, your spark plug is like way up till here, right? And actually by mistake I installed the wrong spark plug, which was all the way till here, but nothing happened. Imagine if my combustion chamber looked differently. Not please remember that not all combustion chambers look like this. This one, they call it the dome or the crown or whatever kind of combustion chamber. Then they have a flat one, which is seriously flat. The valve is just gonna touch it. There is no room. Yeah, so that's what they call an interference type and non-interference type head. Let me not discuss that. We'll go and look for it yourself, because we have nothing to do with that. It does not affect at all in the efficiency, at least to what I know. So we will not discuss with them. So yeah, okay. So so much for that. We've finished the combustion chamber, how it looks like. And obviously this is, the valve. We saw it till here, right? Now above the valve, this is how it is. Remember the springs that I was talking about? This is spring loaded like that, which is hard springs, which can be, you can push it with your hands just like that. And you have this camshaft on top of it. This is just like a cut view of one cylinder. It's a long shaft which goes and does it for all the cylinders, So now, as you can see, that this is timed in such a way when this valve has to open this lobe, right? You call this a lobe on the camshaft. It's gonna rotate and come all the way till here. As soon as it comes here, see now this portion is touching the valve opening thing, whatever this is, right? The rocker or whatever you want to call it. So nothing is gonna happen because there's a clearance. It's just gonna move and rotate. But when this long thing reaches here, since it's taller than the other stuff, when it reaches here, it's gonna, obviously push this thing down, right? It's gonna push your valve stem down and cause your valve to open, right? And it's gonna do it for, let's say, you can, by looking at it, if this is 50% of your diameter, right? This looks like more like a 35 to 40%. So it's gonna keep it open for 40% of the revolution, kind of a thing. That's what I'm assuming by looking at it. So yeah, that's how it works. And the same thing applies to this. As you can see, when this goes down here, this is gonna go here, because both are going on I think counterclockwise. So yeah, this is gonna go, when this reaches down, this is gonna reach like halfway, right? Because obviously when let's assume this is the intake valve and this is the exhaust valve. Obviously that intake and exhaust valve never open simultaneously, right? Yeah, there's some, don't worry about it now. Yeah, for now, it never opens simultaneously. So when it goes down, if it both work together, guess what? If you see this direction, how it's this is pointing that way, right? Let's assume this was also pointing that way. So if it turned together and both of them, they open together, guess what's gonna happen? All your intake mixture is just gonna go out of the exhaust mixture, obviously, because that's the easiest way out. Always remember that pressure looks for the easiest way out to depressurize itself, to escape, so yeah, so that's why this is timed. All this is timed in a certain way that every stroke happens in its own way. Yeah. Now we'll talk about the core components of the engine. This is your main component, the topmost component. Also it is, geographically located on top of the engine. This is your head, your cylinder head. What happens is, like how we saw, this is like a old design of some. This has two valves, right? As you can see, one valve is it has a bigger port than the other one. So you can assume that this is the intake valve right here, and the smaller one is like the exhaust valve. But twin cams, they have 4 valves per cylinder, yeah? So you have 2 valves here, and so we're not going to discuss why they have twin cams and 4 valves per cylinder. That maybe I'm going to make some other videos for that to discuss such lame issues. But right now it does not really affect us, so let's just concentrate on this. So this is where your valve comes out of. Yeah, this is bare right now. So this portion is gonna mate with your cylinder, right? This portion, okay, is gonna mate with your cylinder, and this is your combustion chamber, like almost what we saw in the picture. Yeah, this is the opening for the spark plug, right? Yeah, and you see these holes here, all those funny holes and stuff. So you have your water line, and then you have your oil lines here. You know, I think yeah, the big ones are, I think, your bolt, your head bolts, and the other small ones are like oil line or water line or whatever. So yeah, that's how it goes. So that's your cylinder head, and this is your block. Remember this this part, I said it mates with your block. It sits right on top of this, right? But between them is a gasket, right? Which you must have been hearing all the time: gasket failure, head gasket, and head gasket. This is the gasket. This is a very crucial part, because your combustion chamber is this, you know, I mean, when your piston reaches its max pressure on the TDC, it's right here, right at the edge, right? So imagine it's compressing like 13 times or 10 times or whatever many times, you know. So you have, this whole place is so much pressurized that if your gasket does not seal well, yeah, it's not a joke to have this gas. It's a very complex thing, although it's a simple looking stuff, but it's gonna escape, the pressure is gonna escape from the, you know, it's constantly being pressurized. And you know, that's how they designed it, you know, for they designed an engine to you know, to open up right from the crucial area. You know, that's how smart we are. But you know, only then does it make it possible to be able to overhaul or to, you know, repair the engine internals. Because if we did not have this, you know, how else would we you know, we'll have to actually pull out the whole head with the block completely from down, whereas, you know, it would have been very complicated. So if that's possible, first of all, yeah, it is, because, you know, boxer engines, they have it something similar, but this makes it a lot easier, this kind of design. But if you have a good gasket, it's you know, how are all the engines running flawlessly is because, you know, engines have good gaskets and stuff like that. Yeah, so these here are your water lines, right? Because you need to cool down the explosion that is taking place inside this. This is your cylinder, right? This is where your piston is reciprocating, right? And there's a very slight clearance which is covered by the piston rings, right? So, you know, this wall goes very hot. It goes up to 800 degrees or something like that, yeah, which is very hot. So to bring it down, or to at least maintain it at that temperature, you know. Water is flown from this ports here, you know, they call it the water jacket, you know, around the cylinder. You see, after this much of thickness, you have water cooling this area constantly, right? So that keeps that maintains the temperature of the cylinder so that it does not rise beyond a certain thing, because you know, after a certain degree, you know, every metal has a certain rating, that after that it's gonna start melting or deforming and all that stuff, you know. When it heats up beyond a certain degree, yeah, that's what's gonna happen. So to avoid that, or to maintain a certain thing, you know, this is actually not it's not letting it reach to that optimum point beyond which it's gonna, you know, distort and stuff like that. It's keeping it a couple of I don't know how many degrees cooler than what it's supposed to be. So this is like a precautionary thing, yeah. So that's what is happening inside the mechanics of a block. And then you have the oil lines, yeah, going through it to supply oil to different things. Cylinder, the piston needs oiling at the oil rings, you know. So to, you know, we'll discuss more of that in the lubrication section, yeah. So let's skip this, and you know, the whole point of this was to identify the functionalities of or the, you know, to identify every part of this component, that's all. Now this is your lower block, right? Lower block, where the crankcase goes beneath this, right? And above this is where your crankshaft is seated, right? This is where your crankshaft sits, right? So your crankshaft is bolted here, okay? These are called your mains or main bearings, yeah. And your crankshaft sits here, and then you have main cap, which has another bearing like this, and it's all bolted to that. And then in this end is where you're connecting these gaps, you know, they have they are 180 degree apart from this, going up or down and stuff like that, depending on which cylinder is at which stroke, you know. Don't think that cylinder 1, 2, 3, 4 all do the same stroke at the same time. No, if we did that, the engine would be completely out of balance, right? So cylinder 1, I forgot to mention this earlier, if cylinder 1 is at compression stroke, cylinder 2 is going to be at the power stroke, and cylinder 3 is going to be at the exhaust stroke, and cylinder 4 is going to be at the, you know, intake stroke, some stuff like that, right? So there is a balance. So the power stroke, because power stroke is the only one that makes impact, yeah, because that explosion kind of a thing, that's the one which hammers down and causes that whatever you hear and whatever vibration or whatever thing in the engine you feel is by power stroke happening. So let's say if all the 4 cylinders had to go compression at the same time, you know, compression slows down the momentum. Imagine, so that your engine will move like this. It goes like like that, you know. So it's not gonna be balanced, and that's why once this is pushing up or struggling to push up, you know, compression takes like energy, you know, both the valves are closed, and it's so the power stroke is happening from here, which is, you know, everything is connected to the same crankshaft. So this momentum causes the other one, it helps the other one to go up easy. So it's all balanced out. So compression stroke is also like a shock absorber, because it happens at the opposite, so that's why they balance it in such a way. When this power stroke is gonna happen, this thing is gonna, the compression is gonna slow it down in a way, or absorb the shock of that impact in a certain way. That's balancing is completely other subject. So that's why they have what firing order has the best balance and stuff like that. It's a complete different thing. So yeah, this is where your crankshaft sits, and this needs the best oiling that you can give, there. Anyway, we're going to discuss that also. So these are the thing for the bowls. Yeah, crankshaft bowls are very sensitive also. You have to be very careful about all that stuff. Yeah, and this mates right here underneath the thing, right? This thing is connected, and underneath this is your oil pan and stuff like that, and your oil, what do you call that thing? The oil, I don't know. Yeah. So yeah, this is your crankshaft. Yeah, I think we've dealt with it. There are also some no water lines here, I suppose. Yeah. Okay. So yeah, let's one thing I would want to tell you, that there's a lot of talk with relation to the block. A block could mean different thing. When you say I got my block from Japan, it could mean head, block, and the lower block. Block is a bit ambiguous because you have not mentioned, so you have to know if a layman is saying the block would mean, it could mean all three. Or if you said the technical, not really technical, but it's considered almost technical term, when you say a long block, it means the head mated to the block, mated to this crankcase, right? This is your long block. And your short block could either be only this or this plus this. In most scenarios, it's this plus this, right? Your actual cylinder block and your lower cylinder block, right? So this is your short block. But when you say short block, it can never mean this, and this. Head is never included, right? When you say a long block, it has to mean definitely this plus this plus this. This is your long block, period. So, when you say long or short, when you add that prefix, you're being more specific. So, especially when you deal with vendors and stuff and you want to get your long block, you want to buy it and stuff. So, they tell you that you have to give us your long block core and this and that and stuff like that. So, this is what you have to understand. You might have been reading in the forums the long block, short block. You might think long block means 2.4 and short block means 2.0. That's what I thought for at least half a century, till I discovered by accident it didn't really matter much, but yeah, that's okay. So moving on. Now this is your intake manifold, right? Besides, see, the engine, it is sufficient to have these parts are sufficient to be called together an engine. Like if you have these three things mated together, you can call it an engine, right? That's your long block can actually mean an engine. You can say, yeah, here's my engine. But if you have your head laying around, you can call it an engine. Or if you have your lower block laying around, or your block alone, you can call it an engine. Or if you have your intake manifold laying around, you can call it an engine. But if you have these three parts, it's good enough to be called as an engine, right? So that's your core engine. Now these are the external significant components of the engine, right? So why is that? Because you can actually run the engine without an intake and an exhaust. Yeah, you can do that. It's not gonna be, sweet. It's gonna be destructive. Don't even try it. You can run your engine without an exhaust manifold without any problems. But to test it out, it can catch fire. That's something you have to make your choice, and you have to know your. But intake manifold, without an intake manifold, if you try to run your engine, the RPM is gonna shoot like 59,000, and that's it. You're over. If it starts. So anyway, so intake manifold is the most important component to the engine right after the the core of the engine, which is your long block. So intake manifold is actually, you can call it a big tank, right? It's a tank filled with air, oxygen for your engine, right? What happens is like how this thing mates right here. For example, this is your exhaust valve, but let's look at the other side. We can't see that side, so let's assume it's this side. So this is where it's connected, those ports. So soon as this valve opens, the vacuum inside the cylinder, like how I told you, it's like a pump moving down. When it's moving down, it's gonna suck in the air right from this, right? So when that cylinder goes down, it's gonna suck in the air, and your air is gonna flow in and provide this thing. Yeah. Now what happens? Let's assume that we hooked this up and we started everything, and we cranked it up, and what's gonna happen? Your engine is gonna break in a couple of seconds. Why is that? It's because you have no throttle. If you do not have throttle, your engine is gonna shoot up to 20,000 RPM, unless it has a rev limiter and stuff like that, which obviously you have, and that's it. Because it's when the engine actually demands a lot of air. It's asking, it can take a lot of air also. But how do we control the speed of the engine? It's all by this butterfly. They call this flap a butterfly, which is like a gate. This is your throttle body, which is hooked right here. Yeah, it goes right here. It's mated here. It's sealed and mated here. Yeah. So this is where your throttle cable goes to. Your throttle cable goes at one end to your to your gas pedal, and the other end is hooked right here. So when you push down your gas pedal, it revolves this open, right? This flap revolves and opens. You can imagine that it goes down like that and open. So when it opens a tad bit, the air gushes inside, goes inside, and goes to the cylinder, which is at the compression stroke, which is demanding, and the suction stroke, and demanding the fuel. So it passes the fuel right there. The air. Okay. So so what was I gonna say? Yeah. So this is how you control your speed. The engine speed is controlled by this, right? The more air you open, the computer is gonna recognize that the air has increased, so it's gonna, inject more gas. So see, fuel can be controlled by the computer, right? But air is completely a mechanical thing. We can't control it. We control it mechanically. Even if it's an electronic throttle, the idea is the same. We open it, and the engine actually, by the mechanical force, it sucks in the air. So then we combine it with the proper mixture and send it to the whatever. Yeah, so this is what happens, right? So this is uh, the functionality of the throttle body. Now, what happens is that there's another type of throttle body, which is called the ITBs, the individual throttle bodies. I would want to tell you because it's like a race kind of a thing. It's an performance throttle body, so it has some meaning to it. So I would want to explain this in this opportunity, is that individual throttle bodies are there to prevent a kind of a turbulence, that happens with these type of intakes, which is single throttle body. Although it's negligible for us, but let's just quickly try to understand what happens, right? Let's say, like how I explained to you, that this is like a tank, right? The cylinder at the intake stroke demands air, and the throttle body opens and the air starts going in. Then this cylinder goes into that stroke, the intake stroke. Then this demands it, then this demands it, then this demands it, this demands it. There's like a chaos, right? So the air coming in, right, inside, let's say this thing was demanding it, this cylinder. Then this was demanding it, then this was demanding it. So you can see like a tornado happening inside. Yeah, there's a motion, there's a turbulence that starts happening inside. Yeah, so although these intakes are designed in such a way, there's like a lot of aerodynamics deployed into the thing, but yet it cannot really the best they do, but still they try to minimize the turbulence as much as possible. There's still some kind of turbulence, because obviously the air, when it starts circulating like this and that, and it happens at such a rapid rate that there's like kind of a turbulence. Turbulence is like actually slowing down the motion, right? Kind of a thing. So does not really bother me, but and should not bother most of people, but this is what we have to understand. So some other clever guys, they came up with the individual throttle bodies, which actually I guess I don't have to explain that, gets you rid of this. There's no tank, so no turbulence. Whichever cylinder, you have like these throttle bodies, 6 of them with 6 cables, and then all hooked up to one source, which goes straight to your pedal. So when your pedal, your gas pedal, when you push it in, it does not only revolve one, it revolves all 6 of them in a synchronized way. So all cylinders, get the throttle body opens up, and the suction of this does not disturb the other one, and that's how it goes. So there is no turbulence. So the air goes in a very direct fashion, like that's how it happens. Okay, so that's about it for the intake. And but remember, the cheap intakes, not good really, because they just they don't care about how it is and stuff, and the port could be big here and small inside because of welding in such a way, and not really good. Your nightmare could be if this port is not the same size of that port, and so this one is getting more air than every rest of them. So this obviously you're gonna be injecting fuel equally to all the cylinders, right? So if this one is getting more air, but we are calculating fuel based on the majority of the ports, and so obviously there will be a slight fuel starvation here, which can be, if it's slight, maybe that's not as bad, but if it's, if it's big, you know then you can call it a day and go and look for another engine. Yeah. So yeah, that's why these cheap ass intakes should be avoided. Uh, Chinese ones and stuff like that. But I'm not saying, but yeah, if you've tested out something, and yeah, and especially this throttle body, you know, man, know your thing. Throttle body, a cheap one. I'm a cheap fan. I'm a cheap guy. I like cheap stuff and stuff, but throttle bodies are not worth it like the cheap ones. I've had my experience with a couple of them. Some cheap ones have this problem of sticking, and some of them they have this. There's like a seal on the shaft which starts leaking, and you can lose boost from there, and it's very annoying. It's not nice. So yeah, and throttle bodies, the problem is the original ones are so expensive that so if you don't got a budget, just stick to your OEM intake. That's just good. This one just is just like an eye candy kind of a stuff, and to just flex your muscles a bit, like, and I don't know what this means, but it's really not. Anyway, the OEM guys, they do a lot of research and development on the flow of the intake, so you might as well want to stick to that, unless yeah. Let's move on to the next thing. This is the exhaust manifold. Exhaust manifold has not much to be said, to tell you honestly. Your exhaust comes out and flows to when it comes out, it comes out in this individual pipes which are called your collectors, I think, right? And this is like a headers. Like, I'll explain to you what headers are. So many freaks, Honda guys especially, keep talking about this header 622 to 1, 422 to 1, or 422 or 423 or 42, I don't know what, and collector length and this, and they don't know jack about what's happening, but why does it make a difference? I'm gonna just try to explain to you very quickly. But this is what the thing is. The exhaust comes out from every cylinder. This one goes right here, right? So when your exhaust valve opens, from here right to that pipe, this pipe, and it goes to one common place, and then you have one pipe going down, which is called your down pipe. That's your down pipe. Okay. So looking at this is a turbo manifold. Okay. So don't be shocked if your one does not look like this. But an NA1, almost stuff has it's similar, except that it does not have this, and it does not have this, and it does not have this divided. It's just got a down pipe which goes, and usually this thing is heading down. So anyway, the functionality is the same almost. So I'll tell you about this collector. What's this? This is the only thing what you have to understand in this subject. In your exhaust, why you have this thing, individually coming, is because exhaust is also a pressure, right? Piston, remember, piston is pushing it out, so it's pressurized. So when it's coming here, and let's say this was just teed together, right? Why make 6 pipes? Let's just have them on one pipe, let's say, right? To save some money. So what's going to happen is, since this is pressurized, right? This is pressurized, like I told you, that pressure tries to escape from the shortest route also, yeah? So much of gas is gonna just go here, go to the other neighboring cylinder, right? This gas is gonna go here, this gas is gonna go, this gas is gonna go, this gas, So when this gas goes in this direction, and that gas is also being pushed out, and this gas is going to this, and So again, you have a reverse pressure, you know, which acts like like a, what do you call that thing? Like a, I don't know, man. What do you want to call that? It's actually slowing down the your pressure coming out of your exhaust gas coming out of this. So if it slows down the exhaust gas, obviously it's gonna slow down your piston. Yeah, it's kind of, pushing your piston back. You want a complete free flow, so your piston can come out very easy, right? This is what is called the back pressure, right? Back pressure is that when the exhaust is not escaping fast enough. It's like a back pressure, right? So yeah, try to push a syringe up, yeah, with, blocking half the opening of it. You will feel that pressure, right? So this is what it does. So when you have individual collectors, what happens is that you completely avoid that turbulence happening, you know pressure going from this to that and that to this and this to this. So you have a good thing happening, right? But what happens? This is what I would want to ask some Honda guys and see if they don't, they're the most ones who install headers and stuff. Yeah. So all this is only significant at your lower end, right? At your lower RPM, yeah, at like, let's say 800, 1000, 2000 RPM, your pressure is not that great. Yeah, it's not that great. So this is why this pressure can actually go there, right? Yeah, and it can disturb your flow, right? But at higher RPM, the pressure of the piston is so great that it's gonna push not only this, also this guy's mother. It's gonna push everything out of this. Yeah, the exhaust gas reversing into this thing is meaningless. It can do jack here. Similarly, the intake tank turbulence, which I was talking about, is again the same thing. At higher RPM, all that does not make any difference. At higher RPM, the pressure starts channeling itself, to such a way that it starts flowing how it should flow, right? So at higher RPM, actually, this has now become a restriction. Why is that? Because this is only, let's say, 1 inch or 1.5 inch, let's say, whatever. So it has to travel some distance, it can't, because if it was, let's say, 3 inch, it could send more, right? Which would have been the case if it was teed together. So when you have short collectors, right, when these three make a group of one, for example, right from here, at your high end, they're going to do a good job, because all these three cylinders, instead of being 1 inch, 1 inch, 1 inch, they're going to be 3 inches. So when the pressure becomes greater than all this exhaust bull, it's going to throw out and flow nicely out. You get it? So that's why you can either choose your low end. What do you want? You want the low end, so when your car does not bog down, kind of a thing, and that. So that's so much for that. So yeah, that's how it makes a difference. So usually people try to do everything, especially for the high end and stuff like that. And yeah, I could be a bit wrong in certain things here and there, but this is how it goes. Yeah, if you feel something is wrong, please put it down in the comments and stuff like that. But I really did not feel like it was it was worth my time to go back into this subject and try to understand all this. And again, I'd read all this like millions of years ago. So yeah. Okay, now we come to the very important part of the engine, which is your lubrication. Lubrication has got nothing to do with tuning, right? Maybe exhaust and all have, but why did I bring lubrication? Because lubrication is so important, so crucial, that if your lubrication is not okay, and you're tuning your engine, you're gonna break it like within no seconds, right? So you have to have a general basic idea of how the lubrication is, because you can't, first thing, you can't run an engine without oil. Not for 1 second, not for 2 seconds, not for whatever it is. You can't run it without oil, period. Without water, yes, you can run it till it reaches, a certain degree, and yeah, to test it out and to do that. Although it's not really recommended, but you can do that. There's no harm. You can do that, no problem. Don't listen to people who say you can't do it. So if you are in need and you have to do it, just do it. Don't worry about it. Yeah, but don't let it go beyond, like, let's say 70 degrees and stuff like that. But your oil, no matter what happens, no matter who invades your country, whatever happens, don't run it without oil. It's not gonna last even like a couple of minutes. Not, I think, yeah, maybe a couple of minutes. Anyway, and even if you switch it off, that's it. It's over. You can't fix it. You can't undo that thing. So yeah. Okay, so this is how your oil thing is. Yeah, you pour in your oil from here, your oil can, which is right above your valve cover, right? And then the oil flows down all the way from these oil galleries. Remember, this is your head, the oil lines, right? It flows down all the way. Sorry, you shouldn't have seen this one. Oops. Yeah, it flows down all the way to your oil chamber, right? Your oil pan, your oil collector, whatever thing, oil sump. Yep. So this is your thing. So this is how it works. Here you have that strainer thing, yeah, which is your pickup. Yeah, that's what they call it, pickup. From here, the oil goes through the filter, and then your oil pump, which is driven by the crank, right? Yeah, some pumps are external and they are electrically driven. They are not belt driven, because you don't want the belt to break, because like I told you, it can't run without oil. So if your belt broke, your engine fails right away. So it's connected right at your crankshaft and stuff like that. It's mechanically, so it can never, it fails, but ideally it should never fail. So that's the whole thing. So and it's not like something, it's not a replaceable part just like that you take it out and change at any time. It's built inside the engine. So yeah, so because if your oil pump failed, but you have no choice but to open your engine, because that's it, your engine is damaged. So what's the point of having the oil pump outside the engine? Because you're not gonna just open it to look at it, how it's you're gonna open it when it fails. So that's the whole point. That's why it's built inside the engine. Yeah. So your oil pump takes the oil from here and starts pushing it through these lines, going first to your crankshaft. You can see your crankshaft. Remember those? Sorry, this is your crankshaft. This is an American kind of an engine, I think, or like diesel or whatever. But so it's gonna be a little bit confusing, but does not really matter so much. I didn't really even pay attention to this picture before. I should have. So your oil goes and lubricates the bearings of your crankshaft. So your crankshaft is actually not rotating on the bearings. It's not metal to metal. There is no metal to metal friction. There is oil 24/7 between that. It's like a film, because metal touches metal, that's it. It's gonna heat up, there's friction, there's heat up, and it's gonna bend, it's gonna get scarred, it's gonna get all that stuff, right? So there's always oil between them. That's why you can't run it without oil. Then the same thing goes and feeds the camshaft, whatever is in the rotating assembly. These are also like in bearings and stuff like that. So these things are also, lubricated with oil. So they are also seated inside a film of oil, and they rotate in that. There is no metal to metal contact, right? And then there are other things which come in contact, like these lobes, these push rod thing, whatever that bucket thing is pushing it over. So wherever there is metal to metal contact, there is oil between them, as simple as that. So oil is being supplied to that. And then finally, for your piston, there is oil provided to your or between your oil ring. If the what do you call that, that groove or whatever thing, there's like you will see some holes for the oil thing to come out from there, so that there is never metal to metal. As you can see, this is your piston, it's gonna this is your piston and this is your cylinder, right? Piston is this thing inside, like they've made it like a transparent glass kind of a thing, and inside that your piston is sitting. So you have your oil here. Now why do you have your oil ring? Your oil ring is there so that the oil does not come on top, because if the oil comes on top of the cylinder, it's gonna ruin your mixture, because this area is only supposed to be for your air fuel mixture. Beneath your thing is your oil, so the piston does not really touch the thing. Yeah, that's so much for that. I think, yeah, we've understood this. Yeah, always remember, the first, any filter has to be in the beginning, right at the beginning of any pump. If you have your air filter, it should be right at the beginning of the source. Yeah, it should be right after the source. So this is your source, the filter is right here. If you have a fuel filter, it's advisable that it should be right after your fuel pump, so that your line and everything is clean, and everything else. So filter starts cleaning right from the beginning. Yeah, that's how it. Yeah, so that's your lubrication system in very briefly. Like I said, that certain things I'm gonna keep it brief, because this is just for understanding how it's not a mechanical course. It's just for you to understand that how the oil thing works. So in case you see oil in your plugs, so that oil is on top and oil is in bottom, so you have some ideas, because when tuning you're gonna experience these things. Okay, now the final chapter of this engine composition thing, the final section of this engine composition chapter, is your cooling. Cooling again is simple, like how I said that these are your water jackets. This is where your water has to come. Your water has to flow through this and cool down this, right? But what's gonna happen? The water is gonna, how does the water cool this? Because water absorbs the heat, so the water becomes hot. Now something has to cool down the water. What is that? That's your radiator, right? So your radiator pushes water from here, right? Or maybe it pushes from here. Doesn't really matter. I don't remember now. So maybe if you wanna comment that thing, whatever. So somewhere here or here, there's a thermostat. Thermostat is a valve which is thermo based, which works on your temperature, right? Thermo in Latin means temperature, so whatever. So temperature, how it works is like there's kind of a wax inside the thing that after certain degrees it starts melting. There's a thing, maybe you can look it up on Google, that wax starts melting at this degree. So it's made in such a way with certain mixture that it starts to melt at 88 degrees ideally, and then it allows the water to start flowing. inside. Why does it do that? Because it allows the engine to heat up, to warm up first, because engine, when you turn it on, it's like 30 degrees, let's say, 30 degrees in Dubai, let's say. So what happens when your engine is not really warm? It's not performing so good, because engine performs best at its operating temperature, which is around 80 degrees, right? Before that, the combustion is not 100% complete. Your air fuel mixture is not completely burnt. Yeah, so there is some kind of or sometimes it burns 100%, and at other cycles it burns like 50 percent, then another cycle. So there's, when you have this kind of variation, what's going to happen is the engine will not be balanced, and that's why you feel that slight vibration. Although modern engines, you barely, because there's so many compensations that take care of it. But yeah, that's what happens. So you want a certain temperature. You want your engine to reach a certain temperature quickly as possible. So that's why this gate remains closed. So once it reaches the temperature, water starts flowing and starts going and starts gushing into all these, jackets here, and then it also goes to your heater thing, which is inside your cabin. This is the heater. When you turn the heat on, yeah, this is what happens. Your hot water, after it has sucked in all the heat from all the cylinders, is going to go into this. And if you switch on your heat, there's a valve here, electric valve, which will allow the water to flow through this this thing, what you call it, the coil or whatever, and the fan is gonna blow through it, the heater blower fan, and it's gonna blow in all the hot air, and then that water is gonna flow back and go and supply to the head. Also remember that the combustion chamber, like I told you, is actually in the head. So, and the exhaust is constantly coming out of your exhaust valve. So all those parts also need cooling, otherwise it's gonna bend, or it's gonna get distorted and stuff like that. So you have to supply cooling. You have to provide cooling to all those things to maintain that temperature. So it's gonna follow all that, or I think it goes before this heater, I don't know exactly, and after that it goes back to your radiator, right? And radiator is nothing but it's got like this, it's got this tank, water falling down, for example, into this very skinny pipes, aluminum pipes and stuff like that. And aluminum is known as a good conductor of heat. Good conductor of heat meaning it can conduct, it can absorb the heat or cold fairly quickly. See, remember, there is no such thing as good conductor of heat but bad conductor of cold. No, there's no such thing. What absorbs cold faster, quicker, is gonna also absorb heat in the same proportion, in the same rate, at the same rate. So that's how it goes. People, they say, oh yeah, aluminum, let me make aluminum piping for my thing because it's cold. No, there's no such thing. If it has to heat up, it's gonna heat up, yeah, that fast. But it's gonna cool down also fast, and it's gonna heat up fast, and whatever that is. So yeah, you never get, you can get something which is bad conductor of heat. Like you can actually have a wooden pipe for your intercoolers if you want to do that. If you did that, I can promise you there's zero heat going in, But yeah, that's how it's gonna be. I don't know. Wood is bad conductor of heat. Yeah, I think so. Yeah, because anything that burns is bad conductor of heat. Because what does not bend breaks, something like that. So if you can conduct it, you are not gonna burn, kind of a thing. So metal is not gonna burn. Yeah, maybe after like 50,000 degrees. I'm just kidding, but it's gonna take like but wood it says, no, I'm not gonna, conduct you. I'm not gonna say, because these are all physics, I learned in my imaginary school and stuff like that. So anyways, so the water flows down this thing, yeah, and what happens is, you have fins. Fins are like kind of container for air. So as the fan blows, this fan is actually pulling in, it's a suction kind of a fan which sucks in. And when you're driving at a certain speed, the air is, rushing inside like at this direction. So the air is forced to flow through certain fins. So, air is completely contained. It cannot, like I told you, pressure always tries to escape from the, so if it sees that there is some kind of obstacle here, the air is going to try to reroute itself and go from the easier way. But when you have those fins there, it's going to channel the air in every part of it. So 100% of these those skinny pipes are going to receive that fresh cold air, causing, or at least forcing it, this hot stuff to match with that stuff, because I told you by nature everything wants to normalize. So it's gonna match with its partner, which is this invading air that's rushing inside, and it's gonna cool it down. That's going very deep into the laws of whatever. So that's how it's gonna cool down, and it's gonna send it back to the thing, right? So let's assume that here it's 30 degrees. It goes here, it's still 30 degrees. Then when it reaches here, it's, let's say, 60 degrees, right? This is 60 degrees, no, 80 degrees, because you're actually measuring the water temperature. The water temperature sensor is, yeah. Then it comes back, or let's say it's not, it's more than, yeah, it's 80 degrees also, yeah. Then it comes back here, and as 80 degrees, and then it comes back again here. It's all cooled down. It comes back again to 40 degrees, let's say. I'm just hypothetically saying that. So it depends on how efficient your thing is, and I don't even know how much the efficiency of this. Although I know the efficiency of intercooler, I've taken some readings which I'll be discussing later on. But for radiators, I've never done this kind of experimentation to see exactly what's the efficiency of a radiator. So this is how it's gonna be, yeah. So yeah, it cools down and sends back. So remember the thermostat, like how I was saying, that was to prevent the water from entering, the cold water from entering, so that the temperature in the engine rises as quick as possible. But the other function of this is also to maintain a pressure, right? It also, because once it goes below 88, let's say 88 is supposed to open, so 80, now it's cooled, the thing has cooled it down, so it's reached 80. So this valve is slightly open, so there's a pressure, right? There's a pressure. That pressure actually helps, because the water pump is pushing the water. There's a water pump, I forgot to tell you, because how else is this going to circulate? Everything needs a pump. So there's a water pump somewhere. I think this is the one. This is the one. This one is constantly like, pushing the water around the thing. So the water pump is pushing it, and this one is stopping it. So there is a good collection of water inside this tank, right? So it gives it some time for the fans and for whatever to cool it down. Imagine if there is no pressure here, the water comes here, and boom, within 1 second it's out here. How is it gonna cool down? It does not have enough time, So these are all theories. This is what I've been made to believe. I've not tested it. So, but hypothetically, this is how, or theoretically, this is how it's supposed to, this is how it happened. And if that's why you always need to have, so not a good idea for those guys who ditched thermostat to get some fake gains in their, you know, in their thing, keeping it cool. You know, what they do is they say that, you know, if they have, let's say they have a leakage somewhere here, let's say this was a leaking point, very slight, you know, so there was some evaporation happening and water would reduce after a certain period of time, and so that the cooling efficiency was not so great. So what they think, some smartest mechanics, they tell them, why don't you ditch your thermostat, because it must have gone bad and stuff like that, and you will increase your flow. Because thermostat is only blocking that. So that's all they could understand by the thermostat. So what happens is that when you do that and you run your car, you get amazing results. Yeah, you see that your temperature is not rising at all. Remember when I first told you that the thermostat helps you in reaching that temperature as soon as possible? Yeah, now that one is completely defeated, that purpose. So your temperature does not rise. You keep it running, like let's say for 2 hours, you're still doing like 60, yeah, 60 degrees Celsius. So you're like, wow, that's nice, you know, my gauge is not rising, it's at this, it's low. So when you start driving, let's say you're driving at 120 and you've done like 20 minutes of driving, and then you start seeing that your gauge is rising even slightly above your normal position, right? And then it starts going up and up and up, and then you face the doom. What's happening here is that in the beginning, you know, the engine did not reach that temperature, so it had not reached, and the water had not heated up to that degree, so the water constantly moving around it was able to maintain that temperature, right? Because your EGTs, right, exhaust gas temperature, your cylinder temperature at idling remains, let's say, 400 degrees, 250 to 300 degrees, let's say, right? But when you're stepping on it, it can go also up to 700, right? So when you are doing like 120, let's assume you're doing around 450 plus, right, of your EGT temperature. So 450 of EGT, your cylinder temperature is gonna make this hotter than it should be. So once it reaches that temperature, the water, now the water cannot, does not have enough time spent here to cool down. It's just flowing back into this, right? So that's the reason why it cannot cool down after it has actually heated up, or, you know, reached a certain degree. That's the whole point. Okay, so do not remove your thermostat in case if you wanted to, if you've done your build and stuff like that and it heats up and it's race spec and whatever, you can go for a lower lower thermostat, lower rating, lower degree. Like we've done 68 and it's beautiful, especially for Dubai and stuff. 68 is good even for stock cars, you know, because it just allows the thing to open slightly before the thing, so it maintains a good temperature. It maintains what you see in European countries and stuff like that. So it's nice. So it has a good effect, and we've not failed so far, you know, with that. So you might want to do that. That's very effective. But removing it, like I told you, has no effect. In fact, it has its first effect. So refrain from that. So much for now. And I think this was a long video, but this was important to understand the composition of the engine and how it functions. From the next video onwards, we're going to be looking at the performance parts and stuff and its functionalities. And I know these couple of chapters are going to be slightly boring because you already know and you are anxious about the tuning part. But please bear with us, and we'll see you next time.